Welcome to the Science Simplifier channel. For today we are going to look at linear equations. For linear equations are equations of the form of dy dx plus py is equal to q, where q and p are constants or functions of x. Remember, for these linear equations they are not exact. Now, to make them exact, initially we obtain what we call the integrating factor. After obtaining the integrating factor, you multiply throughout by the integrating factor. Integrating factor is just equal to exponential integral p dx. As you are seeing here, dx, this indicates that this p is just a function of x. Now let us see this equation here. We are having dy dx plus y cot x is equal to cos x. As you are solving this equation, initially make sure that the coefficient of dy dx is 1. Now we are lucky that our coefficient here for dy dx is 1, meaning that we can start. But we start by getting what we call the integrating factor. Now our integrating factor here is equal to exponential integral. Now for our p here will be cot x dx. Integrating factor here is equal to exponential. Now here when we integrate cot x, we are going to obtain ln sin x. But remember, exponential ln is equal to 1, meaning that our integrating factor here, is just equal to sin x. Now from this point we are going to multiply throughout by sin x. That here we are having sin x dy dx plus, here when we multiply by sin x we are going to obtain y cos x being equal to sin x cos x. Now we are going to obtain our main function. Our main function will be dy sin x dx. As you can see our function here. Now it is very simple to obtain this function. Here you just remove this function which is here and you multiply it by this y which is here, meaning that the derivative here, as you can see, y sin x will give us the all of this expression that now we are going to equate it to sin x cos. Now from this point we are going to separate the variables. Now this dx will come this side, that dy sin x is equal to sin x cos x dx. Now we are going to introduce integral signs both sides. Remember, now this d cancels with the integral. We are going to remain with y sin x is equal to, now as you can see here, sin x cos x is the same as a half sin 2x then dx. Now here we are having y sin x is equal to, now when we integrate sin 2x we are going to obtain negative a half cos 2x. But remember, we are having here our half, meaning that now we are going to have negative a quarter cos 2x, then plus constant of integration. Now this one is our answer. Now from there you can try out this number and see whether you have obtained the concept here. You can say maybe dy dx plus y tan x being equal to x. Try out that number so that you can see whether you have grasped the concept.